To perform or to analyze the flow phenomenon of a centrifugal pump, we need to recall our memories from the velocity triangle. And now we have a clear image of two velocity triangles between the inlet and outlet of a centrifugal pump. Now let's say that we have the inlet conditions and the outlet conditions. Assuming that the impeller rotates at a speed of omega here, therefore the blade has a velocity, or the blade velocity, of u. And as we know that the fluids enter the blade with an absolute velocity of c1, and therefore we have the relative velocity of w1 at the inlet. As the impeller rotates, we will have the radial and the axial components of both velocity triangle. So at the outlet, we will have the radial component of CR2, and at the inlet, we will have CR1. As for the outlet, as we have the blade speed, and it is consists of another two velocity components, that is the tangential components of the absolute velocity at the outlet, or Cx2, and the tangential component of the relative velocity, or Wx2. From the previous video, we know that the Euler equation for pump, that is where E is equal to the amount of work divided by mass flow rate multiplied with gravity. And this is equal to the functions of the blade speed at the outlet, u2, multiplied with the tangential components of the absolute velocity at the outlet, or Cx2, minus the conditions at the inlet, divided by gravity. This Euler equations is often called as the Euler hat. It represents the ideal or theoretical hat that being developed by the impeller only by the impeller, not the entire pump. And by recalling our trigonometries, we can estimate that the Cx1, or the tangential components of the absolute velocity at the inlet, is equal to the absolute velocity itself multiplied by the cos of alpha 1, and therefore for the outlet we have Cx2 that is equal to C2 multiplied with cos alpha 2. Then combining these two equations, we get the Euler hat as u2 multiply with c2 cos alpha 2 minus u1 c1 cos alpha 1 divided by gravity. And by using the cosine rule, we can write down that the relative velocity, or W to the power of 2, is equal to the U, the blade speed to the power of 2, plus absolute velocity to the power of 2, minus 2 times U C cos of alpha. Or we can write it down from these equations, become U C cos alpha equal to W to the power of 2 minus U to the power of 2 and minus C to the power of 2 divided by 2. Okay, so this is wrong. It should be minus W plus U and plus C. And this is we can apply for condition 1 for the inlet and condition 2 at the outlet. So let's check again. I think I did it wrong here, so let's erase this. And let's do it again. So blade speed, absolute speed, cos alpha, and then we have U to the power of 2 plus C to the power of 2 minus W to the power of 2 divided by 2. So this is the correct one. And we can apply this to the Euler equation as well. And now that we have the Euler hat, and then by using the cosinus rule, we can rearrange or manipulate the equations, and then we will have that for the inlet conditions, we will have that u1 multiplied by c1 multiplied by cosinus of alpha 1 is equal to u1 to the power of 2 plus c1 to the power of 2 minus w1 to the power of 2 divided by 2. And then for the outlet conditions, we have u2 multiplied by c2 multiplied by cosinus of alpha 2. It will be equal of u2 to the power of 2 plus c2 to the power of 2 minus w2 to the power of 2 divided by 2. Then by substituting these two equations to this, we will have the new form of the Euler hat, that is E is equal to u2 to the power of 2 minus u1 to the power of 2 plus c2 to the power of 2 minus c1 to the power of 2 plus w1 to the power of 2 minus w2 to the power of 2 divided by 2g. And to analyze the flow, we can also use the continuity equations to get the flow rate, or Q, that is equal to the 2p multiplied with the radius multiplied by the radial components of the absolute velocity, or CR, and multiplied by B. So B is the width of the blade. So the blade, other than radius, it also has a width, or it can also be the thickness of the blade. So, and we can use this for the inlet and the outlet.